This is 6.2, part 2. We just did a few problems where we multiplied polynomials together. This is our last example. We have now 2x plus 1 raised to the third power. So in expanded form, it looks like 2x plus 1, another 2x plus 1, and another 2x plus 1. A common mistake students want to do in this problem is they want to distribute this 3 in. So it'd be 2x cubed and then 1 cubed. That is not proper math. So please do not make that common mistake. All right, so on those last examples, we wanted to multiply two polynomials together first. So I'm going to show you a longer way to do this problem and then a shorter way. So I'm just going to FOIL 2x plus 1 and 2x plus 1. So I get 2x times 2x is 4x squared. And then 2x times 1 is 2x. And then 1 times 2x is 2x. And then 1 times 1 is 1. And then I still have this other 2x plus 1 sitting over here. Now I'm just going to combine like terms. So those middle terms become 2x plus 2x is 4x. Now what do I have to do next is I have to distribute 4x squared to the second parentheses, 4x to the second parentheses, and then 1 to the second parentheses. So be very careful on these. So I'm going to take 4x squared and distribute it to 2x. So I get 4x squared times 2x, I multiply the coefficients, 4 times 2 is 8, and then x squared times x, I add the exponents. Now I'm going to distribute 4x squared times 1 is 4x squared. Now I'm going to distribute 4x times 2x. 4 times 2 is 8. X times x is x squared. Then distribute 4x times 1, which is 4x. Then my last wave is 1 times 2x, which is 2x, and then 1 times 1, which is 1. Now I combine any like terms that might be there. So the highest term is 8x cubed. Then I have a pair of like terms here. 4x squared plus 8x squared is 12x squared. Then I have another pair of like terms. 4x plus 2x is 6x. And then I have 1. Now I'm going to show you the problem a different way. You may want to look after this lesson on page 416. They talk about binomial expansion and Pascal's triangle. So that's on page 416. So we're going to take this same equation, I'm just going to bring it down. And now we're going to use the binomial expansion that's in the green. So how this works is through Pascal's triangle. You can save yourself a little time using this rule right here. I would recommend that you write this example down. This is the shortcut way. You identify the A, which is 2x, and then you identify the B, which is 1. And then you throw it into the binomial expansion. So it's saying take A and cube it. So my A in my equation is 2x. So I take 2x and cube it. Make sure you're throwing parentheses around these items. And then plus 3, and then you square A. So 2x squared. And then you multiply it to B. And remember, B is your value of 1. Plus 3. And then times A, which is 2x, and then B squared, which is 1 squared, and then plus B cubed, which is 1 cubed. Now I go ahead and clean it up. 2x cubed represents 2x times 2x times 2x, which is 2 times 2 times 2 is 8. X times x times x is x cubed. Now I'm going to take care of my exponents in the second term here. So 2x times 2x is 4x squared. I'm going to leave that 3 alone for right now, and then the 1 alone. And then over here, I do the same thing again. I take care of those exponents. 1 times 1 is 1. And then 1 times 1 times 1 is 1. Now I'm going to go ahead and multiply coefficients together. So this is still just 8x cubed. And now I multiply 3, 4, and 1 together. And that gives me 12, and then x squared. And then I multiply 3 and 2 and 1 together, which is 6x, and then plus 1. There is a different way to do that problem. Here will be your homework that we will do in class on page 418, 6, 8, 9, and then 19 through 25 odd, 26, 31 to 32, and 39.